Hi, so today I'm looking at equivalent fractions. I'm just going to give you really a bit of an overview of fractions, just a quick rundown on what they're all about. So I'm sure you're already aware, but we have here a half, which is probably one of the most common fractions that people are aware of, even before they start learning them at school. And what a fraction actually means, the top number here is called a numerator, and the bottom number here is called a denominator. And those are the mathematical words that you need to get used to using. What does a fraction really mean? Well, I've got some diagrams underneath. If I was to show you a half, for example, if I take this circle, I always like to think of it in terms of a pizza or a cake or something like that. If I was to cut it in half, what I'm meaning is I cut it so it's exactly through the middle, so you get the same amount on either side. Now, what these two numbers then stand for, the denominator says how many pieces you're cutting, the cake or the pizza or the chocolate or whatever it happens to be, or the money or anything you're dividing up. It's how many pieces it's being divided into, and they must be equal pieces. The numerator then tells you how many of those you're particularly looking at. So we're focusing on what equivalent fractions mean. So here, this is a diagram representing 1/2. So the red shaded section there is 1/2 of my shape, okay, which happens to be a circle. If I was to look at this in a different way and split the same circle, these are supposed to be identical by the way, if I was to split that same circle actually into 4 pieces, and we call that quarter, what would be the equivalent fraction? Well, the equivalent fraction would mean that I would actually need to shade 2 of those pieces. So the fraction would be 2 quarters. Okay, so the 4 says I'm cutting it into 4 pieces. The 2 says I'm looking at 2 of those. And actually I've shaded the same amount on those 2 shapes, but I'm looking at 2 different fractions. I'm looking at them in different ways. So the pieces are smaller, but I'm looking at more of those pieces. Now let's look at the maths, let's look at the numbers here. Well, what I've actually done, if you look at it, is I've multiplied this denominator by 2, and I've done the same with the numerator. I've multiplied it by 2. And that really is the definition, if you like, of equivalent fractions. As long as I keep whatever I do to the numerator and the denominator the same, then I have equivalent fractions. So if you like, I could have multiplied by 100 or 2000 or 1596. It doesn't matter, as long as I do the same to the numerator as I do to the denominator. So I'm going to keep it simple because I've got very simple diagrams, but let's say instead I split this same circle, instead of into 4 pieces, let's now break it down into 8 pieces. So if I've got 8 pieces, how many of those pieces would I need to shade in so that I now have the same amount shaded on the diagrams? Well, if you look at it, I want this bit shaded here. So I shade the same section. I've got 1, 2, 3, 4 of those sections shaded. So that means that my equivalent fraction is 4 out of the total, which is 8, 4/8. Now if I go back to my original, what have I done? I've multiplied the 2 by 4, and, oops, very carefully, I've done the same to the 1. I've multiplied that by 4 as well, and they are equivalent fractions. So as I said, as long as you do the same to the numerator as you do to the denominator, you can be as creative as you like with what you multiply the numerators and denominators by, and you will still get this same equivalent fraction. So as I say, just to be clear, the denominator tells you about the size of the piece that you're looking at. So if we compare our 3 diagrams here, we had 1/2, so the denominator was a 2. Now look at the size of the piece, it's quite large. If someone was going to offer me half a cake, I'd be happy. But now, if we move on to the quarters, the pieces are much smaller. If you look at just one of those, it's smaller than 1/2. So the number is bigger, but actually your piece gets smaller. And now if we look at the eighths, the same happens again. So now I've got a much smaller piece. If I look at one of those, it's much smaller than the quarter and much, much smaller than the half. So in order to have the same amount, I have to really increase that denominator and have a different number of pieces that I'm looking at, okay? And I think it's really interesting that the denominator, as that number increases, actually the size of the piece decreases. It's kind of the opposite to what we would expect to happen. I think that's really interesting about fractions. Right, so a couple of examples here, just some nice, simple, straightforward ones for you. So it's the kind of thing you might get asked. So we've got 4/5 here is equal to 16 over what? Okay, so you've got to work out what's the missing number, okay? And the easiest way to do it is just by saying to yourself, right, what have I multiplied or divided the 4 by to give me 16? Okay, well I've multiplied that by 4. I must therefore have to do the same to the denominator, and therefore your answer, if you do 5 times 4, is 20. So 4/5 is the same as the fraction 16/20. Moving over here, we have 27 over 81, and we've got something over 9. So same principle again. Now this time we've actually divided by something, okay? So the same principle applies whether it's multiply or divide. So what have I done to 81 to make it into 9? I actually divided by 9. So therefore I need to do the same on the top. And if I do 27 divided by 9, I get 3. Now quite often what you're going to be asked to do is to come up with what the number is in its simplest form, in the smallest it could possibly be. So all the examples I did up here, the simplest case was 1/2. So if you got an answer of 4/8, you might simplify it down to 1/2, and that's quite a common thing to do. So if we look at this example here, could we make it any simpler? We've got 3/9. The answer is yes. 3 and 9 have a common factor, and that's really important, and that factor is 3. 3 goes into both of them, and because 3 goes into both of them, 3's into 3 is 1, 3's into 9 is 3, and so therefore the answer is 1/3. Now, just to finish off, I've got 2 last examples for you. But this is not looking at equivalent fractions as such, it's looking at mixed numbers. So I just wanted to give you just a bit of a reminder of how to work with mixed numbers. So first of all, I've got 15 over 2. Now this is actually, in its current format, what we call an improper or top-heavy fraction. And that's because the numerator is actually bigger than the denominator. So 15 over 2 would mean I'd have to have, well, if you think about it, if I'm cutting a cake into 2, one cake is only going to have 2 pieces. So I've got 15 of them, I'm going to need more than one cake. And the question is, how many am I going to need? Now the way to think about this is you say to yourself, right, how many times does 2 go into 15? Because every cake you've got 2 pieces. So it goes in 7 times, because 7 2s are 14. So if you had 7 cakes, you'd have 14 of the halves, okay? So that's a good place to start. But I'd still have 1 more to go because I need 15. We haven't quite got enough to have a whole 8 cakes, but we've got more than 7. So we've got 7 cakes, 7 whole cakes, and you'd have 1 left over, which is your 1/2. So best way to do it under normal circumstances, forgetting about cake for a moment, how many times does 2 go into 15? It goes in 7 times. 7 times 2 is 14. What's left over? 1. So the answer is 7 and 1/2. Next example, same kind of principle. So you say to yourself, here we've got 23 over 4, 23 quarters. So you say to yourself, how many times does 4 go into 23? Well, the closest we can get to in the 4 times table is 20, which is 5. So 5 times 4 is 20. So you've got 5 whole ones. How many have you got left over? Well, you've got 20, so we need 23. So we've got 3 left over. So the answer would be 5 and 3/4. Alright, so get as close as you can with the times table, and then whatever you've got left over, you just put over that denominator just to finish it off. So this would be called an improper fraction, and these parts here are called mixed numbers.